Hey, this is still me. I know I have longer hair because I'm recording this video in a different year than the previous videos. We are going to be talking about dilations. This is Unit 6, Lesson 8 of Pre-Algebra. We're still kind of talking about a lot of the same sorts of things. We're going to be talking about similar figures and we're going to talk dilations. The reason why we're talking about dilations specifically, even though there are three different types of transformations of things. Well, I'll explain this slide here in just a second. But even though there's more than one, we're talking specifically about dilations because dilations are similarity transformations. So let me explain what that means. So there's three different types, primary types of transformations of shapes. One is a reflection, right? Most of these you've seen before, or at least, or even could potentially just understand because the words make sense, right? Because of vocabulary. But reflection is you take a shape and you reflect it over something else. So reflect it from one side to the other, right? Easy peasy. And then a translation is just sliding it over. So like we could translate from this bright green shape to this more light green shape, right? So we from here to there. We call, and you'll see this in an equation, we call the second thing. So like there's the original shape or original figure, and we call its new thing, the new shape that's formed by one of these transformations, we call it its image, right? The image, we translate it to an image. So a dilation is the one we're talking about today. It's where we go from one thing and then we make it either bigger or smaller by a scale factor, right? So dilation is making something bigger or smaller, and let's do some examples. Let's head to that. So our first example is a figure has vertices. I'll read them all as I translate them as we actually do the graphing. Graph the figure and image, see that's that word I was talking about, of the polygon after a dilation with a scale factor of 1/2. So I'm going to start on this graph by graphing the original figure. So I have a graph here. You notice on the graph that I'm using for this particular problem, we're only using quadrant 1 because all of these points are positive, right? So we don't need the other 3 quadrants. So we're gonna graph this just in quadrant 1. So let's graph J. So let's go over 2, up 4, and put us a dot right there, right? And I'm gonna label that as J. Okay, and then K is 2 and then up 6. So 4, 5, 6. So that's K. I'm going to label it K. All right, and then we've got over 8 and then up 6 for M. So over 1, 2, 3, 4, 5, 6, 7, 8. And then up 6. 1, 2, 3, 4, 5, 6. Should be in line with that, right? Because their Y parts are the same. And this one is M. And then N is 8 and then up 2. Up 1, 2. So it's this right here, and that's N. And it says this is a polygon, right? So we are going to connect the dots, right? And that one, and then this one, and then this one, and then this one. So this is the original figure. JKMN, right? Now we need to do a dilation with a scale factor of 1/2. So we need to get our new points. And the new points, we're going to introduce kind of a notation that we sometimes use in math, and that's prime notation. I'll show you what that means here in a second. But so J is 2, 4, right? We're going to translate that and do the dilation, and it's going to give us J prime. So it's it's the one that goes with J, right? We use kind of a little tick mark. It's not a 1, but like a little tick mark. J prime. And in order to find J prime, the dilated portion one of this chord, we're just going to multiply it times the scale factor. So we're going to multiply this times 1/2. So 1/2 times 2. Oops. 1/2 times 2. And 1/2 times 4. Times 4. What's 1/2 times 2? That's easy peasy. That's 1, right? So 1, and then 1/2 times 4 is 2. So I'm going to, as I do this, I'm going to go ahead and graph the dilated image, right? So I'm going to do J prime, which is over 1 up 2. So right here. And I'm going to label it as J prime. Okay. So that's J prime. Let's do K prime. K prime, we're going to do the same way. We're just going to multiply its parts times the scale factor. So if K is 2, 6, we're going to translate that into K prime, which to do that, we just multiply the scale factor. So 1/2 times 2 and 1/2 times 6. What's 1/2 times 2? We already know that that's 1. And what's 1/2 times 6? That's 3, right? So we're going to go over 1 up 1, 2, 3. And we're going to label that as K prime. Hey, let's do it for M. So M is 8, 6. And we're going to translate that into M prime, right? So M prime would be 1/2 the scale factor times 8. And 1/2, which is the scale factor, times 6, which we already did up here, and we already know, right? So M prime, 1/2 times 8 is 4. And 1/2 times 6 is 3. And so we're going to go over 1, 2, 3, 4, up 1, 2, 3. And we're going to label that. Something's wrong. 1, 2, 3. Oh, I labeled K prime wrong. Because of how I did it, I'm going to end up leaving something ugly on my graph. It'll be an ugly hole over here. A testament to my mistake. It's okay. I can count, I promise. I think I counted from J instead of from the bottom, right? I think that's what I did. Or J prime, I mean. So this is actually K prime. This one right here, I'm going to use a little arrow and say this is M prime, right? There we go. And then finally, we're going to do N prime. So N is 8, 2. So we're going to translate that to N prime, which is 1/2 of 8. Oops. I need to do multiply sign, right? Of 8 and 1/2 of 2, right? So N prime is 4, 1. So 4 and 1. This doesn't look right. Did I do something else wrong? Oh, gosh. This whole line was all crazy. J prime should have been 1, 2. I don't know what's happening to me. I'm like drawing this whole line all crazy. All right. Hopefully y'all are doing the advised thing, and you're doing your math in pencil, right? We don't want to do our math in pen. So hopefully that's true. If not, then, well, sorry. Let's make sure we're doing it in pencil next time and use that eraser so you can make it good. So we've got the original figure and its dilated image. Now, the next, I'm not going to write down what I'm saying next because it's more just kind of putting a thought for the future. You notice that when we dilated this, it also moved, right? It didn't just shrink from the middle. And that's because of something called the center of dilation. And in this case, the center of dilation is this 0, 0. And if we were to like draw lines out from there, you would see kind of, I didn't really do that one quite right, but you would see kind of how that's pretty good right there. You can see that it dilates towards that center, right? And so that's not super important. Being able to do this and then being able to plot points, which we've practiced for a long time, those are the most important things. But just kind of that's why it also moves, is because of where the center of dilation is. Let's do another example. This next one we don't have to graph. It doesn't ask us to graph it. So a triangle has vertices at A, excuse me, A1, -2, B0, 2, and C, -2, -1. We're going to find the coordinates of the triangle after a dilation with a scale factor of 2. So to do that, we do just this exact same thing. So we've got A is 1, -2. I have to put my comma, right? 1, -2, and we're going to translate that to A prime, the dilated version of A. And so we're going to do 2, the scale factor, times the components. So 2 times -2, right? And so A prime is 2, -4. And then B, the original B is 0, 2. If you're, I have especially in pre-algebra, I have some students. I often, I don't know what typically, but I often have some students in pre-algebra that are trying at this point of the year to do well and to show their work like they're in algebra and stuff like I expect. And so if you're like, how do I show my work for this? Well, this right here, right? What I'm writing right here is how to show the work, right? And it's just showing those steps that we're taking to get there. So the scale factor times 0, and then the scale factor times 2. So all of this that I'm writing on this particular problem in pink, this would be all the work that you would show on your paper and all of that. So if you're like, I don't know how to show my work, this is how, right? 0, 4. All right, so C was -2, -1. So to find the dilated C prime, we're just going to take the scale factor of 2 and multiply that times -2. And then we're going to take scale factor of 2 and multiply that times -1. So C prime is -4 and -2. These types of problems in this lesson are a little bit tedious, as you've noticed, but they're not really that hard. So it's just, you just got to kind of slow down enough that you don't make silly mistakes, and you can get these real easy. So let's do one more example, kind of going the other way. It'll just take a second or two, and then we're done. So Megan wants to reduce an 8x10 photo to a 2x2.5 inch photo. What is the scale factor of the translation? So this time it is a dilation, right? Because it went from big to little. And it's we instead of writing the new coordinates or the new side lengths or whatever else we might be doing with scale factor, we're actually trying to find the scale factor, right? Now, what we need to think about here is we've got an 8x10, we have an 8x10, and we want to shrink it. We want to shrink it down to a 2x2.5, right? Something like that. So 8x10 to 2x2.5, right? So that's what we're trying to do. We want to know the scale factor. So this is why this is important. You need to think about whether we're going from small to big, or like in this case, we're going big to small. Now, if you're going big to small, your scale factor is going to have a 1 in the numerator, and it's going to have another number in the denominator, right? So it's going to be 1 something, or it could be, well, that's maybe overstating, because it could be like 2/3 or something, but it's going to be our scale factor. If we're going big to small, is going to be less than 1. Less than 1. Right? So it's going to be things like 1/2. These are some examples of possibilities. 1/2 or 1/5 or 2/3, right? Something that's less than 1, right? Because that would, when you multiply it, that would shrink the number. It would make the number smaller. If we're going from small to big, then it would be greater than 1, right? Greater than 1, right? So things like 2. Oops. Things like 2 or 5 or 3.5, right? It's things that are bigger than 1, right? And the reason why this and kind of thinking about this is important is that tells us which way we're going to divide the numbers, okay? So since we're going big to small, we want, when we divide these, to see what the scale factor is or should be or whatever else, we're going to divide them with the little number on the top. So like this first one, and we're going to compare. It should match if we do everything right. That's hard to read. I need to just like delete that color. That's a terrible color for this background. We're going to do 2 to 8, which of course that reduces to 1/4. Now we want to make sure that we're doing everything right and everything's above board and we're all good. And let's do 2.5 divided by 10. Now, that's a little bit trickier, right, to put in your calculator or whatever else, right? Since this is a middle school class, or a kind of a middle school class, this is a pre-algebra class, I want to make sure we're thinking about what we're doing and how to put this in the calculator. Because if you just put, in a lot of calculators, if you put 3.5 and then divide by 10, it's going to give you the wrong answer because it's going to think you want to multiply these numbers, right? So a lot of calculators have a mixed number button. Some of them don't. I'm going to show you how to do it on this calculator, but you may need to do it differently depending on your calculator. So you need to learn how your calculator works, and that's really important. So I have this fraction button here. So I have 2 and 1. Oops. I thought that's what I was doing, but apparently that's not what I'm doing. I want this, but I don't have a mixed number button. Oh, look, there it is. There's my mixed number button. 2 and, what is it? 1/2? 1/2 divided by 10. So see, sometimes oops, that's not right. May have to put it all in. Yep, I do. See, sometimes if it's not working right, you gotta try stuff. And a lot of calculators, you gotta put fraction into parentheses to make it work, right? And so I'm kind of fumbling through this a little bit intentionally. Well, sort of intentionally. I won't claim like absolute brilliance or something, but even if you don't know how to put something in the calculator, you can look at the calculator and find buttons that look like they match what you're trying to do in fraction, right? So just look at it, give it a shot. If you're one of my students, ask me in class. If you're not one of my students and you have a specific calculator, let me know in the comments what calculator you have, and I'll make a quick video about it. I'd be happy to do that. That won't take very long and all those things, right? So we get 0.25, that's what this button is, which is 1/4, right? So back to where we were, this also equals 1/4, which means, lo and behold, our scale factor is in fact 1/4, and we are finished. If you're one of my students, I'll see you in class. Do your homework, all those things, ask good questions. If you're not one of my students, hopefully this was helpful to you. Let us know how else we can help you with math or science or homeschooling in general, all of those things. Have a wonderful day. Bye-bye.